Okay, another limit problem today. As usual, we're going to look at what x is approaching, what the variable is approaching. And if we were to plug 3 in for x squared, actually just do a direct substitution, we would end up with 9 minus 2 times 3, which is 6, minus 3, which would equal 0. And down below, we would end up with 3 squared, or 9, minus 9, which equals 0 as well. And whenever you have 0 divided by 0, that's called indeterminate form. And that's an indication that you need to do something different. In this case, that thing that we're going to do different is called the cancellation technique. And in the cancellation technique, we're going to, at least in this case, factor the numerator, which would become x plus 1 times x minus 3, and the denominator x plus 3 times x minus 3. What's great about this is we see that the x minus 3's divide out, leaving us with a limit as x approaches 3 of x plus 1 divided by x plus 3. Now, one of the things that we struggle with in Algebra 2 is this you can't do, or you shouldn't do, without making a restriction, and the restriction in this case would be provided x does not equal 3. But we don't have to do that here because the limit is not concerned at all with what the value of this function over here is when x equals 3. It's concerned about the function's behavior around the point where x equals 3. And that means we don't really care if this thing is impossible to do over here, dividing out by 0, because we're looking at around x equals 3. Well, once we've eliminated that problem area, we can do a direct substitution. As x approaches 3, x plus 1 becomes 4. As x approaches 3, x plus 3 becomes 6, and we would want to reduce that to 2/3. And that's our solution. Just for the record, the place where x equals 3 represents a removable discontinuity. And if you're not sure what that is, that would be a good thing to review.